Alright guys, I'm back in here. We were talking about where this formula comes from. We're going to prove where it comes from here. This formula really comes from, if you look at it, it kind of looks like 1/2 base times height. Base times height would be a triangle, area of a triangle. Like every other shape in this chapter, we've taken it, we've broken it up into triangles. We took this in case of hexagon and broke it up into 6 triangles. So here's my variables. I put in a little a here for my apothem. I put in s for side length. So I've got, I think it's a 5-step proof on there. As you know, the area of any triangle is 1/2 base times height. Think about it in terms of these two variables. Which one of these would be my base? S would be my base. A would be my height. The area of any one of these triangles, 1, 2, 3, 4, 5, 6 of them, this is the entire triangle here. Area of any one of those triangles would be 1/2. This is my base and that's my height, 1/2 A times S. My apothem times the side length. You could certainly take any one of these and break it up into many little small figures here and say, I'm going to find the area of this triangle, and if there's 6 of them, I'm going to multiply that area by 6. You can do that. That's the long way to do it. This sort of is a shortcut for it. I'll show you where that shortcut comes from. So this is the area of one of these 6 triangles. And again, the apothem on here, if you remember, we found central angles a minute ago. It cut this angle in half. So the apothem is an altitude of that triangle, which in this case is a little isosceles triangle in here, cut it in half so that we had a right angle on here. How many of these triangles are there? The number of triangles depends on the number of sides. If it's a hexagon, there's 1, 2, 3, 4, 5, 6 of these triangles. I'm going to do it in terms of a variable n, because I don't want this to just be a formula for any hexagon. I want it to be any regular polygon. If this was a pentagon, there'd be 5 of these triangles. If it was an octagon, there'd be 8 of these triangles. So n is the number of triangles. Side length is basically, going to tell me, sorry, not side length, the number of sides is going to tell me how many triangles there are. So if I wanted to find the area of this entire thing, I would just take the area of one of these and multiply it by the number of actual triangles there are. Again, area of one of these triangles, multiply it by how many sides there are, or the number of triangles there are. So this is an application of the area addition postulate, which we had a couple days ago, where you can add up areas. The total area of this entire polygon would be the area of one triangle times however many triangles there are. That's what that's saying. This right here is the formula, is the same thing as that. Some of you are looking at it going, how is that the same? This looks like garbage. This looks simple. 1/2, we got the 1/2. A is the apothem. It's like a little altitude. That kind of makes sense. We're finding the area of a triangle, finding the area of an altitude times height, or base times height. Why does S times N equal to P? What is S times N? Again, S was a side length. N was the number of sides. Think about how you find perimeter. If this was 10, how much would the entire perimeter be? It'd be 60. 10 times 6 of them. S times N is P. I mean, the perimeter is the side length times the number of sides. It's another way of finding perimeter if you know it's regular. So just a quick substitution step, and you now have a derivation. You've derived where this formula comes from. The area of any polygon is 1/2 the apothem times the perimeter. So that's just a proof of where this theorem comes from. It comes from breaking up into triangles. Not the most important thing on your notes, but I want to make sure you know it comes from area of a triangle. The rest of this notes is going to be examples. So you're going to have to use some trig on this. You've got, starting with a square or a quadrilateral, a pentagon, and a hexagon. I would pause it and go for it. There's enough information on here you can do this, and you should be able to work from this. The homework assignment, you're going to have to be able to work from here. This is 4 units long. This is 2 units long. This is 10 units long. You should be able to go from here and find the area of these. You may have to look back on your notes, look up above there, and find some information about angles. Without this angle, it's a pretty tough problem to do. It's impossible to do for these two. But you've got to know the measurement of that angle. Square is a little easier because it's a square. So I'm going to kind of let you work on that. I'm going to pause this thing. Maybe I'll throw some angles on here. I don't know. You're using that formula 1/2 apothem times perimeter. Trying to apply that formula. You have to remember those central angles that we found a few minutes ago. Look back on your notes. You have to remember the apothem here. Cut this angle in half. So for the square on your paper, this was 90. That is not a 90-degree angle, clearly. half of 90 is 45, so you got a 45-degree angle on that one. For the pentagon, I believe this whole angle, again I have to draw another radii in here to show it to you, this whole angle was 72. That's not 72, that's 36. Sorry, that's 36, or half of the 72. This is a hexagon. I believe for hexagon this was 60-degree angles all the way here. The apothem cut that in half, that should be 30. So I'm going to post this on a separate site, or a separate part. Work on these three. See if you can get a couple areas on here. I believe, I'll give you some information on here. I believe the apothem should be 2.82 for the first one. The side length, I'm using that for S, should be around 5.675. 657, sorry, which is this whole thing doubled. Perimeter of this thing should be 22.627, which is 4 of these, 4 side lengths. And I believe the area should be 1/2 the apothem times the perimeter, or around 32 square units. So like I said, I'm going to pause this thing. Good luck. We'll give you the next part in a few minutes.